Hey guys, welcome to week 3 of our class. This week will be centered around factoring. What is factoring? Factoring is finding what to multiply together to get a certain expression. For example, we know that when we have to find the factors of 32, we get 1 and 32, 2 and 16, and 4 and 8. These pairs of numbers are the factors of 32. This is exactly what we want to be finding, but now we're going to be using it with expressions. Factoring is one of the most important skills you'll need to develop for future math classes. Factoring helps find many different solutions to problems, such as plotting and solving functions in simple ways. Factoring allows us to simplify the given expression so we can dissect the parts we need. First, we need to understand a few concepts. First concept is the greatest common factor, or the highest number that divides exactly into two or more numbers. So for example, the greatest common factor between 12 and 16 is 4, because 12 is divisible by 4 and 16 is divisible by 4. Next is the distributive property, so a times b plus c is equal to ab plus ac. Next, we need to learn FOIL, which is shown here. X plus y times x plus y is equal to x squared plus 2xy plus y squared. And I'll explain this further. And the final one is form of a quadratic equation, which is ax squared plus bx plus c. So a, b, and c can be any number, just like you've seen in the form of a linear equation, which is y equals ax plus b. Before we start, an important term we need to learn is zeros. So finding where the function hits the x-axis is most likely going to be the most recurring question that you'll have to face in your future math classes. By the use of factoring, we can find these points where the function hits the x-axis. These points are commonly known as x-intercepts or zeros. We find the zeros of the function because that's the way that we find the factors of the function. If we set the function equal to any other number, it would alter the original function. Let's start off with a basic equation. Here we have 6x plus 36. What we want to do is we want to factor it or further simplify this equation. When factoring, you always want to pull out the GCF first if there is a GCF. Here, the GCF has to be a constant because both terms have a constant. You can see here the second one does not have an x. The GCF between 6 and 36 is 6. So we're going to pull a 6 on the side and open a bracket. Next, what we're going to do is we're going to use our knowledge of the distributive property to bring this 6 back to this original equation. So what do we multiply 6 with to get 6x, this first term? Well, it's simple. We just multiply it by x. So 6 times x is equal to 6x. And then we want to get the second term. So what do we multiply 6 by to get 36? Well, we just multiply it by 6. So this is your answer. After we have gotten our answer and see that nothing else can be simplified between the 6 times x plus 6, we can check our answer by using the distributive property. So let me take all this to the side. And let's use the distributive property to see if this is the correct answer. So 6 times x is 6x, and 6 times 6 is 36. And you can see that these answers match. Now, let's move on to this question. 2x cubed plus 4x squared plus 6x. We want to factor this. So first what you want to do is you want to pull out the greatest common factor. Now here we can see that the coefficients are all multiples of 2, 2, 4, 6. And every term has at least one x. This means that we can pull out the greatest common factor, which would be a coefficient and the variable x. So here we can see that the greatest common factor between the coefficients is 2. And we can see that the greatest common factor among the variables is an x right here. So we'll pull out this x. Now we just use the distributive property like we did before to figure out how do we get this 2x into this equation. So what times 2x is equal to 2x cubed? Well, we already have the 2. We need to make this x into x cubed. And to get x cubed, we need to multiply 2x by x squared. To get 4x, we have a 2. To get 4x squared, we already have a 2x. This means that to get this 2 to 4, we need to multiply it by 2. And to get this x to x squared, we need to multiply it by x. Finally, we have 6x. We need to get 2x to 6x. To do that, we just need to get this 2 to 6. To do that, we just multiply by 3, and this is your answer. 2x times x squared plus 2x plus 3. Our next equation is 6x squared y plus 14xy squared minus 42xy. At first, this may seem complicated, but if you stick to the basics, it really isn't. Here, we can see that we have two variables, and we also have constants. So first, let's find the GCF for the constants. Here we can see that we have 6, 14, and 42. Well, 6 doesn't go into 14, so it's not that. 4 doesn't go, but we do have 2. 2 goes into 6, 14, and 42. So we'll pull out a 2. Next, we can see that every term at least has one x, meaning we can pull out an x. And we can also see that every term at least has one y, meaning we can pull out a y. Then we open our parentheses, and we'll use the distributive property to fill in the rest. We need to figure out what multiplied by 2xy is equal to 6x squared y. So we see we need to turn this 2 into 6. So we'll multiply by 3. We need to turn this x into x squared, so we'll multiply by x. And this, we already have a y, so we don't need to do anything there. Next, we have an addition sign, and we need to get this 2 to 14. To do that, we'll multiply by 7. We need to get this x to x, so no change. And we need to get this y to y squared, so we'll just multiply by y. Finally, we need to get this 2xy to minus 42xy. Since this is a positive and we need to turn it a negative, we'll have a negative sign. And what times 2 is equal to 42? Well, that's just 21. Sorry. So this would be our answer. 2xy times 3x plus 7y minus 21. That's how you factor it. This bracket cannot be simplified further because they all have different terms and no greatest common factor. The next type of equation we'll be working with are called difference of squares. This is when there are only two terms and both terms are perfect squares, or could be interchangeable with different types of exponents. Difference of squares for even exponents always have a negative sign in between the two terms. Here we have x squared minus 49. We can tell that this is a perfect square because both terms are perfect squares. The exponent on the x is even, and it is separated by a negative sign. To factor this, we'll need two sets of parentheses. One will be x plus, and the other will be x minus. And I'll explain why in a bit. So here we need to find out what is the square root of the second term, which is 49. So the square root of 49 is 7. So we just fill this in with 7. We can check our answer by applying FOIL. FOIL helps us distribute two parentheses with two terms inside. FOIL is first, outer, inner, and last. This means that we're going to highlight the first term in both parentheses, which is x. We're going to multiply these two terms, so x times x is x squared. Next, we're going to highlight the outer terms, so the closest ones to the edge. Here we have x, and the other outer term is minus 7. So we're going to multiply these two together. This becomes minus 7x. Then we have the inner terms, so the closest together. Here we have plus 7 and x. So plus 7 times x is plus 7x. Finally, we have last, so the last terms in the parentheses. We have 7 times minus 7, which is minus 49. Now, we can see here that minus 7x and plus 7x cancel out. So we're left with x squared minus 49, which is our original equation. If our equation was like this, x squared plus 49, it would be unfactorable. X squared plus 49 does not have any factors because when we set it equal to 0, you can see that x will not be equal to a real number. So if we bring this 49 to the other side, we're left with 49 minus 49, and then we take the square root of x to cancel out this squared. We're left with x is equal to the square root of negative 49. Now, there's something special about this. When there's a negative inside the square root sign, this means that there is not a real number answer. You can only have negative square roots using imaginary numbers, which you'll learn in your future math career. Next, we're going to be moving on to quadratic and cubic functions. Here we have x squared plus 3x minus 10. To factor this, we need to understand FOIL. The first terms must multiply to x squared, the inner and outer terms must add to 3, and the last two terms should multiply to negative 10. This means that we need to find a factor of negative 10 that adds up to 3. Here, I've listed the factors of negative 10. So we have, to get a negative, we need to multiply a positive with a negative. So plus 1 and minus 10 would not work because that adds up to minus 9. Minus 1 and plus 10 would not work because that adds up to 9. Now we can move on to this set. Plus 2 and minus 5 add up to minus 3, which is incorrect. And minus 2 plus 5 add up to 3, so that's correct. Now we know that we need to use minus 2 and plus 5 to factor. Plus 5, there. So we know that our first two terms actually must multiply to x squared. Well, to do that, we need to multiply x by x. Next, we just need to take our two factors and plug them into the brackets. And that's it. This is your answer. We can check our answer by distributing it using FOIL. So x times x is x squared. Minus 2 times x is minus 2x. X times positive 5 is plus 5x. And minus 2 times positive 5 is minus 10. Then we can simplify this into x squared. Minus 2x plus 5x is just plus 3x. And we have the minus 10. As you can see, this is the same as our original equation, meaning this is the correct answer. Here we have 2x squared minus 11x plus 15. Here we can see that we can't pull out a GCF, and we can't find something that multiplies to 2x squared, adds up to minus 11x, and multiplies to 15. Whenever the first term, or a, is not equal to 1, there is a different method to solving. So to solve this, what we need to do is we need to multiply a by c. So here we have a as 2 and c as 15. 2 times 15 is 30. From there, we need to find two numbers that multiply to 30 and add up to negative 11. So we're going to list the factors of 30. Here, I've listed the factors of 30. We can see that minus 5 times minus 6 is equal to positive 30, and minus 5 plus minus 6 is equal to minus 11. We have found our factors. Now, what we want to do is we want to substitute these factors for minus 11x. You want to place the numbers with a GCF corresponding to them. So, for example, here we're going to keep our 2x squared, and we're going to substitute this 11x with minus 6x and minus 5x plus 15, keeping this the same. So you can see that we've grouped them with numbers that have a greatest common factor. Here you can see that 2 and 6 have a greatest common factor of 2, and 5 and 15 have a greatest common factor of 5. So we're going to group these together in pairs of 2. After you've grouped the first two and the last two numbers, what we're going to do is we're going to start pulling out greatest common factors between the two segments. Starting off with the first segment, what we're going to do is we're going to find the greatest common factor between 2x squared and minus 6x. We can see that 2 is found as a multiple in both 2 and minus 6. So we're going to pull out a 2. And here we can see that x is in both parts. So we're going to also pull out an x. Then what we're going to do is we're going to use the reverse distributive property to find out what multiplied by 2x is equal to 2x squared. So 1 multiplied by 2x is equal to 2x squared? Well, simply it's just x. And 1 multiplied by 2x is equal to minus 6x? Well, that's minus 3. We're going to do that in the other part too. We're going to take out a negative 5 because a negative 5 goes into both 15 and negative 5. So what times negative 5 is equal to negative 5x? Well, that's just x. And what times negative 5 is equal to positive 15? It's minus 3. You know you are on the right track when these two match, these two parentheses. So what you want to do is then you want to combine the outer greatest common factors. So we have 2x and minus 5. And we just put it into a parenthesis. And we want to just take one of these. So we have x minus 3. And there's your answer. Our final problem is going to be 12x cubed minus 3x squared minus 28x plus 7. Like always, you want to check for a greatest common factor so you can pull something out to simplify it. Here we can see that there's no greatest common factor because this term does not have an x while the others do, and not all terms are divisible by 3. So what we want to do here is we want to do almost exactly what we did in our previous example for the second half. So we're going to group the first two and the last two terms together. Here we can see that these two have a common factor and these two have a common factor. The common factor between 12x cubed and minus 3x is 3x squared. You can see that 3x squared, what times 3x squared is equal to 12x cubed? Well, it's just 4x. And then what times 3x squared is equal to minus 3x squared? It's just minus 1. Now you want to find the greatest common factor on this side. We're going to find out the greatest common factor is minus 7. So what times minus 7 is equal to 28? Well, it's just 4x, because this also has an x. And what times minus 7 is equal to positive 7? Well, that's just minus 1. And you know this is right when these two match. Just like last time, we're going to combine the two terms that we pulled out. So the 3x squared minus 7. We're going to put it into a parenthesis, and we're going to take one of these factors. We're going to take 4x minus 1. And this is your final answer. I'll explain how to use this information we got from factoring in plotting the function in the next week of our class. If you have any questions, don't be shy to shoot me an email at newyork15@gmail.com or in the class chat. For further help, check out the videos I have linked. I hope you have a good week.